Getting a GenAI demo working is exciting. Getting it safely into production is the real challenge. In this lesson, we'll connect CI/CD, infrastructure as code, and release gates, so your AI systems become repeatable, governed, and ready to scale. You've already built the foundation, how GenAI systems are architected, integrated, and deployed. Now we shift from deciding where workloads run to making delivery repeatable. CI/CD and infrastructure as code turn those designs into governed, production-ready systems. Traditional CI/CD is built around deterministic software. If the code and infrastructure pass their tests, we have reasonable confidence in the release. GenAI changes that equation. A change to a prompt, retrieval data, embeddings, model version, guardrail, or inference setting can shift behavior in unexpected ways. So the pipeline must test more than functionality. It also needs to evaluate answer quality, safety, privacy, latency, and cost. In practice, GenAI CI/CD combines software validation, AI evaluation, governance checks, and operational controls before production. A production LLM pipeline needs more than build and deploy. It begins by validating the source: code quality, dependencies, schemas, prompt templates, and configuration. Automated tests then check behavior across units, APIs, integrations, prompts, and retrieval paths. After that, the pipeline builds and hardens artifacts such as containers, Helm charts, infrastructure plans, SBOMs, and vulnerability scans. The key idea is the gate. Promotion happens only when functional, security, and AI quality checks pass. Once deployed, monitoring, rollback, and audit trails help keep the system safe as models, prompts, and data continue to change. Before judging whether an AI system behaves well, make sure the software around it is solid. Start with code validation. Formatting, linting, type checks, static analysis, and dependency rules catch many issues early. Then unit test the pieces you control, including business logic, prompt construction, retrieval helpers, authentication, and cost estimates. For integration tests, verify that gateways, vector stores, orchestration layers, model endpoints, and external tools work together. Use mocked LLM responses for repeatable tests and reserve live model calls for a small set of controlled end-to-end checks. Treat every prompt change like a code change. Regression tests should compare the candidate prompt against a trusted baseline using representative tasks and golden examples. Evaluation works best when methods are combined: human review for nuance, rubric scoring for consistency, and LLM as judge when it has been validated for the task. Measure what matters: groundedness, helpfulness, refusal accuracy, toxicity, PII leakage, and format validity. If scores fall below threshold or a safety risk appears, the pipeline stops. That gate prevents quiet quality regressions from reaching users. After tests pass, the pipeline turns source code into an immutable artifact. The container image is uniquely tagged with the commit SHA, version, environment, and build details, so everyone knows exactly what is being deployed. The pipeline then generates an SBOM, giving a full inventory of libraries, model clients, runtime components, and transitive dependencies. Scanners check the image, dependencies, infrastructure code, and Kubernetes manifests for vulnerabilities or policy violations. Only approved artifacts are signed, enriched with provenance metadata, and pushed to a trusted registry with controlled access. In GenAI platforms, infrastructure should be treated like application code. The same review, testing, and release discipline applies to compute, networking, secrets, API gateways, model endpoints, databases, vector stores, queues, and observability. A strong pattern is to build reusable platform modules, then layer application-specific settings and environment overlays for dev, test, and production. Everything lives in version control and flows through deployment pipelines. The result is repeatability, faster recovery, and fewer manual production changes. Most importantly, declarative desired state helps prevent drift as AI workloads evolve. Terraform and Pulumi both turn infrastructure into versioned, reviewable code, which is critical when GenAI platforms span many cloud services. Terraform is often chosen for its declarative model, mature providers, and strong repeatability across teams. Pulumi offers a more software-native experience, letting engineers define resources in languages like Python, TypeScript, Go, or C#. In practice, both support state previews or plans, policies, and approvals. The priority is to package common GenAI building blocks, such as vector databases, GPU pools, model gateways, private networks, IAM, and monitoring, into reusable modules or components. For GenAI on Kubernetes, deployment configuration often changes across dev, test, and production. Helm solves the packaging problem by turning manifests into reusable charts, with templates, values, dependencies, and release history. Kustomize solves the customization problem by applying overlays to a shared base, so teams avoid copying YAML. Common differences include model endpoints, vector database references, replica counts, resource limits, tracing, and guardrail services. Before anything reaches the cluster, validate the generated manifests. Catch missing secrets, insecure defaults, and resource mistakes early when they are cheap to fix. GitOps turns deployment into a controlled reconciliation loop. A developer changes manifests in Git, opens a pull request, and the change passes review and policy checks before it becomes the approved desired state. Controllers like Argo CD or Flux then compare that desired state with what is actually running and continuously sync the environment. If someone changes production directly, the controller detects drift and can restore the declared configuration. Rollback becomes another Git operation. Revert the commit or redeploy an approved version. For GenAI, this same pattern protects prompts, routing, guardrails, and runtime settings. Think of environment promotion as increasing evidence before increasing exposure. In development, teams move fast, using mocks, synthetic data, smaller models, and cheaper resources to explore ideas safely. Staging is where the system starts proving itself against production-like integrations, prompts, retrieval, security controls, and observability. Pre-production becomes the final rehearsal, closely matching production for load tests, evaluation gates, release checks, and approvals. Only then should production receive the change, with restricted access, audited configuration, monitored rollout, and a rollback plan ready. Promotion across development, staging, and production is safe only when each environment is truly isolated. Keep provider choices, API keys, database endpoints, rate limits, and feature flags separate, so a test change cannot leak into production. Secrets should live in a secret manager, accessed through workload identity, never committed to Git or embedded in manifests. Test data needs the same discipline. Use curated datasets for prompt evaluation, RAG quality, safety checks, adversarial cases, and regressions. Avoid raw production PII in lower environments. Prefer synthetic, anonymized, or tightly governed samples. Before a GenAI change reaches users, it should pass more than a functional test. Release gates turn risk into explicit go, no-go decisions. Quality gates ask whether answers are relevant, grounded, accurate, properly cited, and complete. Safety and security gates challenge the system with prompt injection, jailbreaks, PII exposure, toxicity, and authorization edge cases. Performance gates confirm latency, throughput, timeouts, retrieval speed, and provider reliability under realistic load. Cost gates check token budgets, caching, routing, and expected spend per workflow. If any gate fails, the release is blocked or investigated, not quietly accepted. Reliable GenAI delivery depends on automation you can trust. CI/CD adds prompt tests, evaluation gates, RAG checks, safety controls, and cost guardrails. Infrastructure as code and GitOps keep environments reproducible and auditable. Promotion from dev to production requires isolation, policies, observability, and rollback plans. Next, we'll focus on versioning models, prompts, data, and RAG indexes.